Welcome, everyone. Super excited about this particular shareholder investor webinar, AI the next 5 years. I'm sure we're all very excited to hear what our experts have to say about, where AI is going in the next 5 years. Basically, I'll go into introductions of Rick and Matt Marshall from VentureBeat. Then we'll have a conversation between the two of those folks on the next 5 years. What's going to change? What are we getting excited about? What do we need to be concerned about? It's also an opportunity for you all to think about questions that you have for both Rick and Matt as they're discussing, because we will be opening it up to Q&A after. Before we kick this off, we, as usual, are showing our legal disclaimer. So I'll pause and just let you quickly take a look at this. Kathleen is also putting it in the chat so that you guys can take a look at it at your leisure. So I'll give you like 10 seconds to read it briefly. Okay, so with that, I'm excited to bring on Rick Bentley, our founder and CEO, who's really been one of probably the longest standing AI experts in the Valley, I would imagine, 20 years history or more. And Matt Marshall on the media side, also equally is involved with AI and where it's going for many, many years. So super excited to have both of you and excited about the conversation. Before we get started, though, some of you might not know as much about VentureBeat as others. And so Matt, just give us a brief outline of VentureBeat.
Yeah, thanks, Lauren. Thanks for inviting me, and excited to discuss this with Rick and everyone. But VentureBeat was founded about 15 years ago. I started this in my bedroom. I'm the founder and editor-in-chief. We're a publication that writes about enterprise technology for technical decision makers. And we're covering the story of transformation in the modern enterprise, mainly around how companies are harnessing all this data they're getting. As you know, they're getting it from mobile, they're getting it from the supply chain, getting it around their customers. It's exploding. How do they harness this data and then build applications like AI that are increasingly powerful? So that is a revolution that's happening in just about every enterprise. And so we want to do a pure play focus on that as a publication. We also have a games channel where we focus on the gaming industry for gaming leaders. But what I'm involved in personally, and a good part of the rest of the company, is this enterprise agenda. And we also host events. So that's where we have this metaphorical town square concept where we're having millions of readers coming in, trying to learn about technology, attending our events, and then connecting them with service providers, folks who can answer their questions, maybe serve their technology needs. So that's a brief intro of and what you see on the slide are the main channels within this data strategy area that we're covering.
Awesome. Great. Well, thanks for joining us today, Matt. Okay, so I think we're going to kick it off as a conversation. And Matt, you're really the mediator, moderator here in the conversation, and also bringing forth your ideas as you converse with Rick. So take it away.
Yeah. Thanks, Lauren. Rick, again, great to be here with you. This is our first conversation, but familiar with Cloudastructure, and we want to dig in a little deeper on the company, but also just the environment that you're operating in and what we're seeing here at VentureBeat. I think we should have a good conversation. I think by way of intro, over the last 8 years or so, we've seen this emergence of AI as a powerful force, and VentureBeat just jumped in as soon as we saw that around 2015. It kind of really hit critical mass with the emergence of things like chatbots and some fundamental breakthroughs in deep learning algorithms, started by folks in the bowels of Google and other research organizations, where these algorithms, for the first time, were really detecting patterns in imagery and recognizing and generating now speech in ways that a human could, and actually increasingly in some ways that exceed human ability to detect whether a cheetah a picture of a cheetah is actually a cheetah or not. AI has created some really good predictive, excellent predictive recommendation engines. I think all people participating today are familiar with the algorithms from Amazon, Google's algorithms on search results. A lot of that is fueled by AI and these algorithms that now have just kind of gone beyond those early players and seeping into just about everything we do on the web today. There's an algorithm, right? So for a while over those years, again, starting around 8 years ago, there was this kind of steady emergence and learning from enterprise companies how to adopt conversational AI, right? The chatbots and so on. Computer vision started getting adopted. I think to tease it here, to bring it to a point, over the last 6 months, something more fundamental has happened. There's been this breakthrough by a company called OpenAI. This has been long in the making by a number of different players, but OpenAI really brought it to the forefront. This idea of generative AI, using large language models to actually generate text as though it is essentially a human. And what they're doing is they're taking, the open web, all those conversations we've had over the years that are in text, and this is being done on the image side as well, but being able to allow search engines to respond to a query, not just the text with multiple links of results, but to actually respond with an answer that is actually almost better, and as I say, sometimes better than a human because of the raw knowledge that it brings. And so that excitement called it's generative AI, known as ChatGPT, which is the solution that OpenAI released and which has been adopted by Microsoft and Satya, one of the largest market cap companies out there. Satya, the CEO, Satya Nadella, saying this is one of the biggest revolutions, and it's set off a whole arms race with Google announcing Code Red to figure out how it responds. So the titans are trembling and in a race to figure this out. And then you have these players, I think like Rick's Cloudastructure, that have been in there working on these foundational technologies and computer vision. And so, I'd really like to get started with some conversations now, more practically, with that as an intro, Rick. Right? I think we see some benefits, obviously, to the public, right? I mean, more efficiency, saving time, not having to wade through results, but also being able to generate text as though you're a fluent kind of the Shakespeare, actually literally being able to generate Shakespearean chapters at whim, and then of course the problems that can potentially yield with this problem of hallucination, where actually the algorithms aren't really people, but they're generating sometimes misinformation that's out there on the web, and that can be hugely problematic. And so there's a wave of scientists that have said, "Hey, let's pause on this. This is so dangerous. Let's pause all development for the next 6 months." And so it's causing a lot of people to lean in. So Rick, let's talk about what you're seeing on your side of the industry. Do you agree with what I just said in terms of the hype out there and where we are? Or would you edit that somehow?
Yeah, I would say there is a lot of hype. By the way, I'm in Truckee, California. I left the Bay Area during the lockdowns and very smugly sat up here with my fast wireless broadband connection. And then our historic snowfall is a little obscured by snow. So I did some digging yesterday to clear out the antennas. But if I fuzz out, let me know, and I'll be happy to repeat anything that got a little garbled.
You're doing great, Rick. So we can see.
Okay, fantastic. So I would like to kind of just set some terminology real quick. I think AI and machine learning get thrown around and used almost interchangeably sometimes, and it might be helpful to just pause for a second and do kind of a definition set. AI is not new. I'm in my 50s. My grandparents grew up with AI. Every person on this call has AI in their home right now. Probably the simplest example of AI is your thermostat. Your thermostat has two thoughts. It's not warm enough in here, and it is warm enough in here, right? And then it turns on the furnace accordingly. And that really is, by any definition, artificial intelligence. It's not very sophisticated, but it's been around for a long time and we take it for granted, right? So fast forward to ChatGPT, which I think is getting all the attention right now. And by the way, ChatGPT is by no means the largest large language model out there. NVIDIA and others have, I mean, everyone, Google, Facebook, they've all done deep dives on this at this point. Like you said, the Titans are aware of what's going on with almost an order of magnitude more parameters and computational power behind them, right? ChatGPT did a good job of opening it up with the appropriate filters and maybe inappropriate filters on the front end. A couple of years ago, Microsoft opened one up and it pretty quickly got very politically incorrect, right? Almost became like a Nazi apologist or something. And they had to shut it off. It's a little bit of an embarrassment, right? But ChatGPT has some filters, some that you can tease out and some that you can't. And it really has changed. This is very much like the last company I started was backed by SoftBank in the .com boom. And after a long fuse, it was bought by Uber after a merger and some other stuff. But that was the wild west of the internet. When I started that company, Televoke, in 1998, later became Jakarta. Televoke back then, anyone back then, you could do anything you wanted to on the web. You could do pets.com because no one had done a pets.com yet, right? And you could maybe even raise $1 billion for it. That's because all the frameworks were in place. There's HTML and there's backend databases, and you could put everything together and make it work. Now with these large language models, you can do the same thing again for anything you can think of, and the territory hasn't been claimed or staked out yet. And there's multiple backends available. There's all sorts of air in the space to do anything. I mean, we always thought that when AI got here, it'd be replacing truck drivers and warehouse workers and people lower on the economic scale. And now it's really looking like it's gonna replace doctors and lawyers first, right? It really is a difference in what people thought was gonna be happening.
So Rick, I think that's a great reset in terms of the conversation. You're just showing the richness of the evolvement over time. So this is an acceleration. You've got the ChatGPT. Let's move to computer vision. I mean, a lot of the excitement, again, when I was referring to in terms of this inflection point in terms of enterprise usage about 8 years ago, where all enterprise companies started saying, "Hey, let's get some of this AI." It actually was started with a breakthrough in ImageNet. So this goes way back in terms of the area that you're involved in. Can you talk about what you're seeing in computer vision? A lot of the excitement in ChatGPT is around chat. Talk about if you would about the computer vision side of things.
These large language models, many of them are multimodal input, which means you can show it a picture, for example, and it can create a picture or even a video in return. You're going to see more and more of that, I think. The real breakthroughs in computer vision, especially the ones we use at Cloudastructure, are based around AI. So, back to the thermostat model, it has two thoughts. It's warm enough, it's not warm enough. A machine learning thermostat would say, oh, Matt comes downstairs around 8 a.m. every morning and tells me to be warmer. And around 6 p.m. he tells me to be cooler. I'll just anticipate that. And I'll set myself ahead in the morning and back at night. Right? That'd be a machine learning thermostat. Now in computer vision, just a few years ago, 5 years ago, certainly 8, I was at Google in 2015 working full-time at Google X when Google open sourced TensorFlow. It was the first machine learning platform and that was readily available to the masses. Before machine learning platforms, if you wanted to teach a computer how to mechanize a car, for example, you with your little monkey brain, or me with my little monkey brain, would have to explain to a computer what a car looks like. Hey, it's got these black things at the bottom called tires or wheels, and it's kind of got glass on the top, and they're sort of shiny. They come in almost every color. And sometimes the lights on the front are white, and sometimes the ones on the back are red, and sometimes the ones on the side. Trying to explain to a computer what a car looks like so it can detect cars for you. And not surprisingly, it does a pretty bad job, right? With machine learning, you tell the computer, hey, look, here's 10,000 pictures of cars, and here's 50,000 pictures of not cars, but could be confusingly similar, like airplanes or motorcycles or mailboxes or whatever, right? And at the end of that, if you have the right machine learning platform, the computer knows how to detect a car better than you could ever explain to it, right? And that's machine learning has been the breakthrough for computer vision. I can go in more examples, more in depth if you want, but I'll pause there.
Yeah, no, that's really helpful in terms of the breakthroughs in computer vision. So that set off a mini revolution of companies that are labeling imagery so that these algorithms can be fed images appropriately, and so you have a lot of offerings out there. Could you talk a little bit, maybe now closer to Cloudastructure and what you're doing practically?
Yeah, one of the things people like on computer vision, we do video surveillance in the cloud. We push all the video to the cloud. In the cloud, we have access to large computational clusters that you can't afford to put in an NVR, a network video recorder, at every location. So we can just do a lot more with the video. And the first thing we do is we index all the video. So just like Google indexed the web, so you search for kittens, it already knows where all the kittens are. For us, if you search for a person or car or backpack, we don't know in all of your video where all the people, cars, and backpacks are, right? So we can bring them up right away. But more interesting than object detection like that, like person or face, is recognition. So a face detection would be, I detected a face. Face recognition would be, I see Matt, right? And that's been a big feature for us, because it allows you to do things like, okay, well, where did Matt go today? Or that guy who spray painted the side of the building or harassed the lady in the parking lot, where else has he been across all of our locations in the last month, right? And you can never really sort through all that video once you got even dozens, much less hundreds of cameras, and do that sort of searching. But we allow it to happen. And for artificial intelligence, along the way, people have always thought, well, it'll never be as good as a human, right? They said about chess computers for a long time, and now chess computers trounce all humans who play chess. And the same thing happened maybe 5 years ago with computer vision and face recognition. There's a data set called Label Faces in the Wild. It's not people taking studio shots like we are right now. It's people walking down the street and past surveillance cameras. And you take 1,000 pictures of people's faces, and you dump them on a table in front of humans, and you say, sort these all into piles. So put all the Laurens in one pile, all the Ricks in one pile, and all the Matts in another pile, and do that for as many faces as you can find. And humans take a long time to do that, but when they're done, they're about 5 years ago, that face recognition was also about 96% accurate. And now the stuff we're using and doing is 99 point something percent accurate, right? It's exceeded the ability of humans to recognize faces now. And that's just a fascinating breakthrough, right? We have millions of years of evolution detecting faces. Hey, there's a human there and he's watching me, right? We even have that kind of sixth sense of being watched, right? Where we haven't even quite seen the face yet, but we know something's going on. Millions of years of evolution with a giant neural net in our heads. And in the last 5 years, computers have just blown by us with that.
Rick, thanks for that context. I think that brings us up to the present, where we saw really interesting. By the way, I see some questions occasionally, or comments on chat. Feel free to pose your question in that chat. I think Rick and I will continue just to sort through a few remaining topics here, and then we'll go to maybe a Q&A. So, Rick, there was a time a couple of years ago where all of a sudden all the big players in computer vision put a stop, right? I should say big hyperscale companies, Amazon, Microsoft, Google, put a stop on some of their computer vision efforts because of the controversy around things like privacy. There's stories around people getting arrested wrongly because the image recognition actually thought that this person looked very similar to that person, but because the lack of perfection, this person was wrongly charged and in fact arrested, and then let go after some period of time, and that can create a lot of frustration, obviously, and it's unfair sometimes, where there's considerations on algorithms. People of color maybe tested less frequently, and therefore the algorithms haven't been as effective on people of color versus as others. And the privacy conversations around having these cameras tracking folks. Can you talk a little bit about where we stand in that conversation, right? I mean, just for every conversation against computer surveillance, occasionally you have an argument that pops up for it, right? We saw the beatings of of a young man to death by police because there was a camera tracking it across the street. And so that was beneficial for society to actually catch some of that and charge the people that were behind that. So can you talk a little bit about where we stand from the business side in terms of using some of this technology?
Everyone has a camera in their pocket now. That wasn't 20 years ago. Every building has a camera on it now, for the most part, any commercial building. You know, that wasn't true, again, 10, 15 years ago. And so there is a lot of video generated. And if you can sort through, pretty powerful. I will say that some companies have rescinded their product offerings of things like face recognition, you know, Google being one. Google still uses face recognition inside of Google products. If you use Google Photos or whatever else, it'll gladly take your photos and sort them all, right? And you know, Google was the one back in the day with that product that identified the African-American family as gorillas, right? They applied the gorilla tag. And that was obviously massively embarrassing to them. Google wasn't making a lot of money selling their face recognition tools, right? Other places were. Amazon was, and Amazon still is, as part of the AWS offering. You can still get face recognition from Amazon. It's very powerful. We think we have stuff, we think we use stuff that's better, and the stuff we built we think is better. But you know, we're competing against giants here, right? If we were to use Amazon, we would spend all of our revenue on face recognition on Amazon, object detection on Amazon, instead of rolling our own, right? And being competitors in the space instead of just a customer. I think you're going to see a lot of positioning in this space. Oh, for ethical purposes, we're not going to be involved. We're not going to make these things public. I don't see anyone making billions of dollars a year on a product line doing that. I think people who are losing money that. I think there'll be plenty of other entities, large and small, to come in and fill the gap. Once the genie's out of the bottle, you can't put it back in. You know, nuclear weaponry was something that came out, and it's, you know, coming up on a century old, this half century old. We couldn't keep that secret. You know, pretty soon it proliferated and everyone had it. Same thing in the technology space, right? Once you can do something, you can't put the genie back in the bottle.
Yeah, absolutely. There's a certain glory, I think, to pursuing that technology, right, of where it goes. And you're always going to have folks who are going to be pushing that. It's going to be hard to put a stop to that. Absolutely. So I see some questions rolling in. You know, what can we expect to see in the next 5 years, right? Someone says they want to hear about Skynet, computer vision, and AI. What's exciting? What's not so exciting? Maybe some of the specific, more specific applications. What do companies actually need?
You know, what are we going to see going forward with all this stuff? Well, there's a lot of stuff that's always going to be part of the imagination and sci-fi and won't ever really be real. My favorite one in video surveillance, it's like, well, if that person takes up 8 pixels and we only recorded 8 pixels, you know, 2 wide, 4 high, there's nothing to zoom in and enhance except to show you bigger pixels, right? You could ask the computer to guess what is in there, and that might get you to the same problem you were talking about before of people being falsely accused and everything else, right? You know, who knows what goes on inside a deep mind, right? That's this kind of amorphous box. I do know that there's going to be more and more tuning of the inputs and outputs to get answers that the hosts of these applications want to provide. That's going to be very interesting. You know, Google already does it with search a lot, where they make sure they get you the answers that they want you to see, and they block searches they don't want you to see, et cetera. You know, up rank and down rank answers. And the same thing's happening with these large chatbots as well. I think you'll see them be more tightly groomed and less neutral arbiters of information.
Yeah, Rick, one thing that you've touched on is the deep fake phenomenon, you know, videos that are created to look like something, but they're not really. I think there's a little bit of an arms race going on between, you know, bad actors who can generate this this stuff with AI, but then also, the good folks who are trying to stop it. It's sometimes those are folks within the enterprise trying to create trust, and also, frankly, consumers trying to figure out, was that Joe Biden talking in a slurred speech, or was it a fake video? Can you talk a little bit about where that deep fake video challenge goes for you over the next 5 years? Do you think that the good guys will stay ahead of the bad actors, or vice versa?
I think that genie's already out of the bottle. 10 years ago, you couldn't trust any picture you saw. You could have anyone shaking hands with Osama bin Laden if you wanted to, right? As a single frame still. A video is just 24 of those per second for however long the video clip is, right? And already we're past the point where you can reliably tell what's been faked and what has. You make some educated guesses. You can say, oh, that doesn't quite look right. It's not quite smooth enough. You can run it through algorithms who say, it looks like this was generated. So anyone can fake a video too.
That's right. Hey, so we talk a little bit about. I think you've raised the concept of chain of custody. Could you talk a little bit about that?
It's important to know where the video came from, right? MSNBC recorded a speech by Joe Biden. They have the original footage, and they can show that original footage because it came from MSNBC. They recorded it. It's been in their vault, and they can say, look, his speech here, surprisingly maybe, is not slurred, right? Whereas someone else could take the speech, take that same video after it's out in the wild, edit it and re-release it, put it on Reddit or whatever that show his speech is slurred. And unless you can get back to that source video, you can never really prove, which one's which, right? So the chain of custody and video surveillance is the same thing. It's really about who recorded it, and are they the one representing that this is the actual video, right? And can they prove it? And that's something we spend a lot of time at Cloudastructure to make sure that we can always make sure, especially since we're cloud-based, we can pull up the source video, and we can show if it's been altered or not.
Rick, I've seen some questions come over chat. There was a question. Tom asked, any strategy around conversational AI, chat GPT? Anything more you want to go there into in terms of strategy?
At Cloudastructure, we're we have the ability to search through the video. We can do Boolean type of searches like red car, right? Instead of just car or just anything red. I think we're going to end up pretty quickly here with a natural language interface for the person can type out, show me all red cars in the last 30 days. So rather than typing red plus car and adjusting the window of time to 30 days automatically. Does that really set the world on fire? I don't think so. But I think it's becoming expected in human computer interfaces now to be able to just talk to it normally like that. And so that's something we'll be adopting as well.
Right. And then obviously, I think you've already talked to the fact that some of this generative AI can actually generate video. And so you need to stay ahead in terms of that authentication and the chain of custody. So I guess because there's a couple of strategies there that you have. Another attendee, we want to make sure people keep asking their questions. We can get to those. Asks, what is the downside of this technology, and how do we safeguard ourselves? I think we've touched on a couple of points. Maybe for the consumer side of technologies, but also generally. Any other thoughts that you have, Rick, in terms of how to safeguard ourselves?
Yeah, I guess the first question is safeguard against what, right? If it's job loss, we may not want to, right? We create technology so we can free ourselves from labor. The problem is going to end up with a lot of unemployed people. But if I was going to write me a car contract, his name, my name, make and model of the car, and it would do a fine job of that, that'd probably be good enough for both of us, right? And so will that displace some lawyers? For sure, right? Is that bad? Probably not. That's probably good, unless you're a lawyer, right? When it becomes alive and self-replicates itself, and we can't turn it off, and is able to bypass firewalls and change databases to suit its purposes and do what it wants to do, I think that's highly unlikely. But there's a whole lot of imagination and sci-fi around it that's very intriguing to think about, right? I think this recent letter that Wozniak and Musk and some others put together asking for a 6-month hiatus on AI is more of a publicity stunt, so they sound relevant more than either hoping that they'll do it. I think they admitted as much that they don't expect anyone to do it, or an actual cry of alarm. I think there's going to be changes. I think change is usually good. It's not always good, but in net, technology advancement is almost always good, right? So I think that's what's going to happen.
Yeah, great, Rick. Going down through the questions, there's another person who's asking, this is, I refer to the leopard or a computer guessing what is a cheetah versus a cat better than a human can, and you're talking about video deciding what's a fight versus a dance. This seems pretty straightforward, but how do you measure progress in cat type ID, or in Cloudastructure's case, identifying people searching for keys versus picking a lock?
One of the big frontiers of computer vision, it still is an idea called persistence. And this is, right now, almost all object detection and face recognition is done off of a single frame of video, right? Here's the picture of Rick, we're going to recognize that face. Here's the picture of the cat, we're going to recognize that image, right? And let's say you or I are sitting at home and the front door is open because it's a warm day, and a dog pokes his head in the door. At first, we'd be like, oh my gosh, what is that, right? I wasn't expecting that. What is that? And you look and the dog walks in, you're like, oh, it's not a wolf, it's not a coyote, it's a dog. It turns sideways, you see the profile shot, it's a golden retriever, right? You pet it. So it walks out the room and it leaves. And you are 100% sure somewhere in that chain that is a golden retriever, and your confidence stays at 100% all the way until it leaves, right? But when it first walks in, you're very unsure. So let's say how a computer looks at it. A computer is processing this frame by frame. So the dog sticks its head in the door, and it's the same thing. It's like, hey, 72% dog, 18% wolf, 10% coyote, right? And those are my best guesses. It walks in, it turns sideways, you get that classic profile shot of a dog, and it's like, oh yeah, totally a dog, right? So the human and the computer are doing the same thing at first. Start at low confidence, go up to 100% confidence, but here's where the difference happens. That dog turns around and walks out, all the computer sees is its butt, and now it thinks it's a couch cushion, right? Or a chair or something, because it doesn't have that previous context. It doesn't have the persistence of its understanding of what that object is, right? Now, so, why don't we just process every frame and stick them all together? Well, the memory space for that becomes really large, right? So the computational costs go way up. Cloudastructure, we're already starting to take persistence into account. So if you have a camera in the rain, for example, right? Raindrops get on the lens. There's raindrops flying past the camera. It's very difficult to see much of anything. But just like humans in the Rorschach test, those ink blots that psychologists will give you to see, what do you see? Oh, I see, flying elephants, or, I see my mother or whatever, right? And they're supposed to get some insight to your psychology off of that. They've been around, for a century, right? The computer will start to imagine what it sees also, right? Because like if you look at the clouds, at some point you can see a face or a car or something in the clouds, right? Just by looking at the shapes changing. So when we have impaired vision situations like this, we still want to be looking, but we don't want to be taking a Rorschach test. So we already have things going on where we say, okay, we just saw a frame of a person. Well, what was the frame before, and the frame before that, and the frame after, and the frame after that? And was there still a person there, or was this just like a raindrop going by that for one frame looked like a person, right? So we're starting to do some basic persistence, which, believe it or not, is really on the forefront of computer vision right now. When you're processing video instead of still images, taking this sort of stuff into account is important. Just like the example with the dog. If you don't do it, you'll have weird, wacky outputs unless you take the previous history into account.
Great, Rick. There's another question I want to make sure I get to. Does automation equal AI? I think I don't know where that was posed when you were going through the basic setup. I think you may have addressed it a little bit in terms of definitionally. I think, the industry talks about robotic process automation as a separate category than AI. People interchange the terms a lot. Anything to add there real briefly before we move on to the next question, Rick?
Yeah, I think these definitions are fluid, right? I think what was amazing to people 100 years ago, they would call AI back then like a thermostat, which we don't now. I don't think automation necessarily equates to AI. An assembly line for manufacturing is automated, but is in no way intelligent. It doesn't have any thoughts, I don't think. Maybe you could break out certain parts of it and say, hey, and here's the stage where it checks to weigh it to make sure it has the right amount of stuff in it before it goes to the next stage. And maybe that used to be done by a human, and maybe consider knowing that weight and making a decision off of it is some sort of rudimentary intelligence, right? I think today we've raised the standard really high. I remember my grandfather and grandmother explained to me in the Model T Ford they had and the first motorcycle my grandfather had, you had to advance the ignition while the RPMs went up. There was, when the spark plug fired was fixed unless you advance that. And it was really something when they had automatic advancing ignitions, which we just all take for granted now, right? We probably don't call that part of our car AI anymore. We probably call self-driving AI now, right? But by any solid definition, they're both some manner of intelligence that is automated.
Right. Yeah, and the goalposts are going to keep changing, and so generative AI is going to be old hat in a year or two. But that we'll be excited about the next new thing probably. Speaking of which, let's switch to Jerry from Tampa. Asks, can Rick speak about how quantum computers will change society within the next 5 years or so?
Quantum computers meet their promise of the last 10 years. Then in the next 5 years, they could really change society. Whether or not they meet their promise, that's going to be an interesting question. I had several semesters of quantum mechanics as a physics major at Berkeley. And I have I think a pretty good understanding of how a quantum computer works and what the proposition is. If it really could do computations on things that aren't optimized for quantum computers really fast, like breaking public-private key pair encryption, which is what cryptocurrency and computer passwords and a lot of stuff is based upon, then it could be game, right? If all of a sudden everything that was secret wasn't secret, that would just, people could never catch up with that, right? Now, I think the fact of the matter is the quantum computers are really good at solving problems that are specialized for quantum computers, and public-private key pair encryption is not yet one of them, right? So if quantum computing meets the hype, it's going to change the world. Will it meet the hype? It hasn't yet. It's been promised for a while. Everyone else catches up and we get longer passwords or whatever we need, multi-factor security, et cetera. And we headed off at the pass, right? I think we're all going to be safe from quantum computing, but it does have the potential in the computations that it is designed for to really do some fascinating stuff. Many orders of magnitude faster than regular silicon. And will that change the world? We'll see. I think the jury's still out.
Great. Okay, jury's still out on quantum. That's what the story's been over the last couple of years. Gartner, with its famous hype cycle report, talked about it being 10 years away, but I see it bobbing back and forth, and so again, it's pretty conjecture ridden right now. Let's keep going. Does your AI products? I think we're back to Cloudastructure here, Rick. Do your AI products include voice recognition or just facial?
We're just doing face right now. There's a legal framework in the US about recording voice. Some states have two-party consent, where the person being recorded and the person recording both have to consent to that voice being recorded. Some states have single-party consent, but there's federal wiretapping laws, et cetera, that you can run afoul if you just have a hidden microphone somewhere, which could be in a security camera. recording conversations all the time. We haven't been doing much with audio in general, or voice in particular, at Cloudastructure. The request comes up now and again. It's just not, it's not the hot topic right now, right? For us, it's really been the computer vision, the face recognition, license plate reading, and most recently remote guarding. And there's this line between artificial intelligence and human intelligence, right? And we're pretty cognizant of where that line is. And at some point, you want to hand off the problem to a human. You want to take the computer out of the loop, right? And that might be, for example, hey, this office is pretty busy in the daytime, but if anyone comes by the front door, the vestibule, the atrium, whatever, after hours, maybe we have a human take a look at that to see what they're up to, right? And the reason for that is, someone walking up to their key for a little bit and then opening it to a computer really looks a lot like someone forcing open a door with a small pry bar, right? It's just not something the computer can reliably distinguish. So you have the human pop in and take a look, right? And those humans then can do a talk down, and this is where voice comes into play in a different way. They can say, hey, yes, you in the gray sweater and the black pants, you are on video. This is a restricted area. There's no trespassing. We're calling private security and the police, right? And the person gets out of there. And for the customer, for video surveillance value, the value of the video surveillance system just went through the roof, right? Before, they were going to get some forensic data the next morning of who broke into their office and what they stole and what time it happened. And maybe they can give the video to the police and maybe they'll recognize the guy. But nowadays, they're wearing a hoodie and a COVID mask and they have gloves on. You can't even tell the color of their skin, right? So you can't get anything useful off of someone who's gussied up like that. But if they're by voice waved off the scene at night, and the next morning the building owner or occupant or whatever comes back, has a report that someone tried to break in last night and we scared them off, it's a very different value to the system, right? Instead of the smashed door and the missing equipment, you just have a report. It turns video surveillance and the AI solution from something that is just after the fact, here, we got robbed, what are we going to do about it, to preventative. So from crime responsive to crime prevention. And that's the line again between AI and human intelligence. And as much as all for AI exceeding humans in every category, it's not yet. So I think the best systems, which I think we have one of the best systems, and I think the best systems will always have that quick handoff to a human when required, even if it's transparent to the user, right? Even if they don't know that. When the AI has a low confidence, the human steps in, I think that's going to be the most powerful systems that we're going to see for the next 5 years.
Great. So with the blow up of AI in society today, where do you feel your position against the big companies is in the lineup? Good question.
It's interesting, right? Every big company has a team of people working on something that's bigger than every startup, right? So no matter what you do for a startup, there's something that you use, some technology you need, and Google or Microsoft or IBM or Amazon has a team 10 times bigger than yours working on just that problem, right? And then you have to decide, okay, are we going to rent or buy that technology from them? Are we going to build that technology on our own and compete against them? Or are we going to team up with everyone else and find an open source solution that is competitive? And time again, we see the open source solutions being superior to the private endeavors, right? When you have the ability for anyone, anywhere on the planet, to step in and lend their skills and intelligence and abilities to it, you really often see a superior product. What you don't see is all the marketing and support that goes behind the private offering, right? On the flip side, again, what you do see are forums and bulletin boards and the ability for Google and GitHub and everyone else just to find what you're looking for, right? I think there's a saying amongst programmers, the best line of code is the line we didn't write. If you're looking to do something and you go to GitHub, you can probably find what you're looking for, right? you can probably find something that you can copy and paste. And man, the edge cases. Here's an example of how people always underestimate the solo development effort, right? Time zones. Sounds pretty easy, right? There's 24 of them. So it should be pretty easy to record the video and note what time zone it was recorded in, and then play it back appropriately in the time zone of the user who's watching it. Sure. There's also daylight savings time. And some time zones are, some time zones are off by a half hour, not a full hour. And there's leap year, and there's leap seconds. And there's all sorts of stuff that just off of time, you'll find there's so many edge cases. You can get 95% of it right in the first place by saying, hey, there's 24 time zones and there's daylight savings time. And then you'll really mess up 5% of the time. Or you can grab code off of GitHub where someone has just done everything already with time zones. They've run down every edge case. Some PhD student somewhere did a thesis on it. Some guy made it his hobby in India and he ran it down to the nth degree because that was just his favorite thing to do. And all this is now available and you can grab it. Or you can try and buy some sort of time zone thing from Amazon and Microsoft that just has a lot of people involved with it. It doesn't have the whole world involved with it like open source does, right? And so I think we'll see a lot of open source tools in the next 5 years. I think they'll eclipse pretty quickly as the space opens up and gets smart, these private developments, even by the giants. It'll be interesting to watch, especially when it happens to the large language models, to the chat GPTs of the world.
Yeah, that's great. And we see these things time and again. I mean, you look at OpenAI emerged and became the source of this latest revolution. It bears reminding, right? Everyone thought that the revolution was moving away. Tech revolution was moving away from Silicon Valley. In some ways, the world is flat, and it has. But I think last time I checked, OpenAI's office is down in missions somewhere. And Microsoft licensed the technology, gave it $1 billion, and you see a startup emerge and do some great things. I think that story will be told over and over again, right? The big players often get in their own way and kill decent projects because they just don't offer the scale. They get in that prisoner's dilemma. So there's all kinds of reasons I think why this is going to be fertile ground. I don't know if we moved on, Rick, from quantum. Maybe you said your piece there. I did see a question there about whether there's anything more specifically that AI will have to play there. Will it be affected if it's integrated with quantum? Anything else there, or should we move on?
I don't think so. I think, again, quantum computers are really good at solving problems that are uniquely suited to quantum computers, right? And they're much faster than basic silicon chips for that. But they have yet to prove themselves as being generally applicable to other problems like, public-private key pair encryption, which much of the world is based upon. Okay.
And another question is, what type of government regulations, you have touched on this briefly at the very beginning, but is AI going to face?
It's beyond me to predict what Congress is going to do, right? I don't think they're going to face anything for a while. All the big incumbents own their own senators, so we have the best government money can buy. So when things started to get displaced, maybe lawyers will get legislation passed, or doctors will get legislation passed to not allow AI to provide services that are licensed by the states, right? So you can't ask the AI a legal question and say, I don't have a legal license. You can't ask the AI a medical question and say, I don't have a medical license. Maybe that'll happen, and maybe they'll find that they can pass the bar and they can pass the MCATs at a level much higher than any human can, and maybe they'll get licensed. Who knows, right? At least that way the government can get their piece of it. I'm hoping that government stays out of it for as long as possible. That's what will really give us the greatest growth opportunity with the least amount of interference. But who knows? When those getting displaced, call up their bought and paid for politicians, they'll pass whatever legislation they want to get passed, right? So we'll see what comes out of it.
Great, Rick. So we're nearing the end here. I think it's probably a good time. I think we've addressed a lot of the questions, but maybe we could do a wrap-up summary of the theme of this talk today. We've covered a lot of ground. What does AI look like in the next 5 years? I think there's some questions from attendees circling around the big picture here, right? You've got quantum, computer vision, chat GPT, privacy, and regulation. How would you summarize the conversation today, and any other thoughts, Rick, in terms of AI over the next 5 years?
Well, I think from Cloudastructure standpoint, computer vision's already exceeded human vision and face recognition and other tasks. I think as persistence comes along, that's the last frontier for computer vision. That I think that will likely be solved in the next 5 years. Whether or not it's practical to sell at scale, it will be the remaining question. But I think once persistence is around, the computers remember what they saw and they can make more logical deductions about what they're looking at now. That's gonna be a game changer for computer vision. I think the chatbots are huge right now. I think they're going to displace white collar workers first, unlike what we thought AI was going to do. They're going to replace truck drivers and warehouse workers. I think it's going to replace the professionals first. I think that's going to be a big shakeup in society. We'll see what sort of immune response those industries have to being displaced, right? Maybe they can get government to slow things down. I think it's inevitable though. I think 5 years is probably the time horizon where, you're going to need lawyers for some pretty complex transactions, but for 90% of current legal work, you're not going to for contracts and even resolution and things like that. Other changes, we've been looking at the self-driving car forever. I think in 5 years, that'll finally be complete. I think the accident rate for computer drivers, AI drivers, will be lower than human drivers pretty soon. I think that'll happen within 5 years. I don't think quantum computing is going to displace that. I'll be enough time the world to prepare for it. So I think that one might be a little overblown. And that's my summary of my predictions.
Thanks, Matt and Rick. I'll take it here and close everyone. What a great conversation and awesome questions from the audience. Just really exciting. Just so everyone knows, there will be a recording of this posted on our invest.cloudastructure.com website. I'm just going to share my screen real quick in the closing. If you want to learn more about Cloudastructure on the invest side, go to www.buycloudshares.com or investcloudastructure.com. And then also join us next time, May 4th, 9 a.m., Investing in AI, What to Look For. And Rick will be our host, as well as a gentleman from King's Crowd, which it should be an exciting conversation as well. So look for the link in the chat, and thanks all for joining.
Thanks, Matt. Thanks, everyone. This is a lot of fun.
Okay.
Yeah, thanks, Lauren. Thanks, Rick.
Okay.
Thanks, everyone.
Everybody.
Okay. Thanks, Matt.
Bye-bye.